Hi everyone, and welcome to the lesson. In this lesson, we're going to be talking about the roots of an equation. This lesson is just a quick review of what roots of an equation are. So I have the review in roots of an equation, zeros of an equation, the solutions of an equation. So first of all, let's start with the roots of an equation. Let's go. Root of an equation. The roots of an equation can be defined or described as the values of the variable that makes the equation to equal to 0. They are also known, roots of an equation are also known as the x-intercepts of the graph of an equation. Just if you are dealing with a graph, the zeros of an equation if you're also dealing with a graph, or algebraically, the solutions of an equation if you are dealing with the equation algebraically or graphically. Yes, the roots of an equation. Now, I like to use these two examples to demonstrate the concept. The first one is a linear equation, y is equal to 5 minus x. Second one is a quadratic equation, y is equal to x squared minus 5x plus 4. Now, I want you to remember there are three things we said. One, the roots of an equation are also known as the x-intercepts. They are also known as the zeros of an equation. They are also known as the solutions of an equation. In terms of the zeros, we can use algebraic methods to find out the values of the variable that make the equation equal to 0. So let's try this. Taking the first one, if we're looking for the value of x that will make the equation to be equal to 0, even though it is simple as it looks, because all you can do is just say, okay, x is 5. 5 minus 5 is 0. We can do that. But we have to do it algebraically by saying, okay, for the equation to be 0, that means y will be equal to 0. So we can say, remember, an equation is a statement that whatever happens on the left must equally happen on the right. So if we say let y be 0, then we can also say let 5 minus x equal to 0. So in this case, 5 minus x is equal to 0. Simple algebraic manipulation. Bring the like terms on one side and unlike terms on the other side. So if we add x on both sides, that will give me 5 minus x plus x is equal to 0 plus x. So this will cancel this, that will be equal to 5 is equal to x. Therefore, x equal to 5 is a value of the variable that will make this equation equal to 0, because if you sub in 5, it will give you 0. So x equal to 5 is the root of the equation. That is by algebraic method. Let's try the second equation, which is a quadratic equation. Y is equal to x squared minus 5x plus 4. So the values of x that will make the equation equal to 0. This one looks a little more complicated because we have to break the equation into its factors. So let's try this. Let y be equal to 0 on the left side. If that's the case, then x squared minus 5x plus 4 will also be equal to 0. So let's see. Now, if x squared minus 5x plus 4 is equal to 0, then the only way we can do it is to factor the equation. So this will translate to, I'll just go straight to the factors. X minus 1 bracket x minus 4 is equal to 0. Remember, if two numbers multiply each other to equate to 0, it means that either one of them is a 0 or both of them are zeros. So in this case, x minus 1 is either equal to 0 or both of them are equal to 0. If that's the case, then we can say x minus 1 is equal to 0, therefore x is equal to 1. Here, x minus 4 is equal to 0, therefore x is equal to 4. So what are we saying here? That means the values of x that will make that equation equal to 0 are 1 and 4. If you sub in 1 here, you are going to get a 0. If you sub in 4 here, you're going to get a 0. Therefore, algebraically, we have determined the values of the variables that will make the equation equal to 0. Those values also are the roots of the equation. Next, let's use a graphical method to find the x-intercept, which is the same thing as the zeros of the equation. So for the first equation, the linear equation, the graph is a straight line. You can see that in blue here, a straight line. And that graph cuts the x-axis at a point 5. And at that point, y is equal to 0. So this point 5 and 0 represents the point where the graph cuts the x-intercept. And that point is also known as the 0 of that equation. The value of x at that point makes the equation equal to 0. Like we said, that point is 5. If you sub in 5, you're going to get a 0. So that is for the linear equation. Then, for the quadratic equation, remember we had 2 points. X is equal to 1 and x is equal to 4. So if you look at this graph, you notice that the graph cuts the x-intercept at 1 and 0, and here 4 and 0. So those are the x-intercepts, and those points represent the roots of the equation as well as the zeros of the equation. So you can find whatever you're looking for depending on what you require. If you are given an equation and you are required to find the roots, in other words, you don't have the graph, you can use algebraic manipulation to find the roots or the zeros. Okay? Then, if you are given a graph, you can quickly look at the graph and locate the points where the graph called the x-intercept. Those are the roots and those are the zeros as well. Now, yes, so you can see that's why they are called the same thing in different ways. The zeros, the x-intercept, and the roots. So all this is represent the roots of an equation. Next is also one of the characterization of the roots of an equation. That is, the roots of an equation are also known as the solution of that equation. And what's the solution of equation? The solution of an equation is the value of the variable that makes that equation to be true, or that statement to be true, or the value of the variable that satisfies the equation. So let's take a look at this graph again. You notice that the x-intercept of the linear equation is at 5. Therefore, 5 and 0 is a solution to the graph. That means, and that solution is peculiar to that graph, that solution, 5 and 0. Okay? You cannot have any other 5 and 0. as a solution. Rather, you can have other values as a solution to the same graph, but at different points on the graph. For example, if you pick any point on this graph anywhere, it will satisfy that equation. It will make the equation to be true. Yes, that's why it's called a solution. But the x-intercept, the root or the zeros, is a peculiar type of solution. Yes, x-intercept. Then for a quadratic equation, something happens. At these 2 points also satisfy the equation. These 2 points also make the equation to be true. Those 2 points are the solutions of the equation. So, and also to remind you, remember, a solution of equation means that whatever is on the left side will always be equal to what is on the right side. Whatever is on the right side will have equivalent value on the left side. So look at this graph. The one in red, that's a quadratic. We have 2 points. Those 2 points are the particular solutions to the graph. So long as this graph is there. But remember, if you move the graph down and up, those values will change. But we're not talking about that now. So now, any point on the graph satisfies the equation. For example, if you take a point here which is x coordinate of 5 and y coordinate of 4, if you sub in 5 into this equation, you are going to get a value of 4. This point is 6 and 10. If you sub in 6 into the equation, you are going to get a y value of 10. So those points satisfy the equation. But those points are solutions. They are not the roots of the equation, but they satisfy they are solutions. See the difference now? This root is particular when y is equal to 0. Here, the y's are not zeros, so they cannot be a particular, so they cannot be the roots or the zeros. The only thing that can be the roots or zeros will be that. So you can see how the roots of an equation are got. Now, roots of an equation also can be described in, can be characterized, or can be, it can be characterized as number 1, the equation has no roots. Yes. Number 2, the equation has 1 root, 2 roots, 3 roots, 4 roots, and so on and so forth. Infinite number of roots. How do we know which one is which? I will explain that in the next video.